Essentially, the principle of concrete is the engineer is going to have in his structural notes, he's going to say, I want concrete at X PSI, which essentially is usually between 3,000 and 4,000 PSI. And we can measure that by crushing the samples that we mold, curing them, and then crushing them there. But we actually collect them when they're wet concrete in the field from behind the truck. So the finished product would be, these are the 4x8 samples. Most samples, they don't do anything except they're hard, and then they just start going, and you watch the dial go up, and it just starts declining. You know, sometimes they'll have a little pop if you load them really fast. So this is a 400,000 pound press on this here, so it has a lot of capacity, but it's very slow.
Sure.
You know, just like you can't see it, but it's actually lifting right now. In a sample like this, I can run this up for a while. I know it's going to have an idea. Like even right now, I'm at over 10,000 pounds. I've got it loaded to right now, and it's probably going to go up to like 80,000 on this little sample. So essentially, that little 4-inch diameter circle is going to hold over 80,000 pounds. And my guess is it'll probably break around that. Typically, when I get up so high, I usually will close this ring and shattering like that. But it's starting to weaken down, so there you go. So by loading it fast, you can see what it does. So you can see almost the way it's built that the load drove itself from top to bottom right down through each other, the 2 points. And then you can even see, they even have here where there's actually a piece of wood from the concrete.
Oh, that fell into the concrete.
Even in the rock, it was probably in the rock.
Oh, okay.
Because they harvest off the river bars around here a lot. So essentially this equipment here is what they use for ASTM test methods, which is a dry density of the sample soils. The material, the mold you have to use is relative to the particle size. So standard test is the ASTM 1557, which uses this hammer, which essentially is 10 pounds that drops from 18 inches high, and you drop it a specified number of blows depending on which mold you're using. So essentially I take a sample, usually have as received or close, and you'll sprinkle it out in the bottom. And they allow you to kind of spread it out and get it there. And so I'm trying to get my first layer, and then I'm going to have to go around. They want you to kind of go around in a spiral motion to get 56 blows. And just to speed the process up, I'll just kind of cut that in half and build my layers up. And the reason is that they want uniformity across the test method. So they have a known weight, a known drop, and a number of blows and a number of layers. So when everybody's in theory, you would get somewhat similar results. So essentially, I need to strike this off, which would be so I have my piece of mold that it's already been, I know the volume of. And then the test method says to kind of fill the voids equal to the little particles that are above. So you end up with trying to repair. Some samples aren't so granular, so they're a little easier. You take the total weight, you subtract it from the tear, multiply it by the volume to get your wet density. But that's only part of the test, because the other side of the test, you need to know your moisture content so you can do your dry density, which is what the test method is looking for. So I can take this apart once I've got my total volume weight to get my wet density. And then this will just pop it right out of there. essentially you have a completed sample and it has some density to it. Now it's a little soft, so it probably means that you would be, the optimum moisture is probably a little bit lower, where it'd be a little bit denser, because as you can see it has a little bit of give to it. Usually when we get done with the optimum point, it's rock hard. And you try to provide them the information that, you know, it's okay, so my curve shows optimum is say 11% and my gauge is reading, you know, 16 to 20%. I said you can't get back to get compaction until you take moisture out of the soil. So we always try to say, you know, inform them what's going on. If it's too wet or too dry, because you can have the same thing on the dry side. You know, they don't have enough moisture in it. They may have to run a water truck in it. They may have to blend it up, especially like you go to like the road base. This works good in winter because it dries out, but also same problem in summertime. If they don't add water to it, it just turns into a bunch of BBs and marbles sitting around, and then when they try to compact it with a roller, it just bounces around because there's not really any water to help bind it together. So it can be the opposite in the summertime where you need to add water. This same whole principle is applied to is if you're putting a trench through a parking lot, a storm drain, you know, plumbing trenches underneath curb and gutter, sidewalks, you know, roads, road improvements, anything like that. You would use the same principle. We actually have a license with the Radiological Health Branch of the state of California that allows us to have these gauges in our possession, and we have a monitoring system. I have a film badge that records all the exposure I'm getting when I'm operating the gauge. We have a film badge up on the wall up there high. Essentially, they transport this here. They rest in here, and they have double locked, 2 different locks that we have, and then we have a chain that we have to chain the thing up into our vehicle, and it's chained up through the handles, around it, through the locks, and locked and chained in the vehicle. So the gauge is just a rod that's exposed into the ground, and it's just inside that rod is a double encapsulated, welded shut ceramic pellet that has radioactive components. And essentially what the gauge on the base of the gauge has is it has 2 sensors, one that measures the 2 different types of radiation. One picks up for density and one picks up for moisture. And then it takes the 2, and then when you expose this rod in the ground, you do it for a known amount of time that the gauge is calibrated to. If this test I did in the lab, I had 145 was my pounds per cubic foot, and I measured with the gauge and they needed 90% of that, you would calculate what it is, and they need to be like around 130 some, their values would have to be, beat that. So you're measuring what we can do in the lab, and this measures what they can do in the field. It just depends on what the contractor's doing. Is if they're filling the material very slowly and you're there a lot, you know, you're just there, you're standing there anyhow. You may just take every time they finish rolling something, you may just test behind them. You know, and I think a lot of times if they are doing a big area and if they're getting good results, your testing frequency, you start off heavy testing and then you kind of back off as you know that their means and methods are working. And then you're just more there for verification purposes, you know. But if you're having problems with them not passing, then you usually increase your testing. A lot of times what happens is Eric gets the foundation from the structural engineer and he asks them to make changes or modifies it to meet his requirements. So that's really where the teaming comes up a lot of times. And then we'll do a lot of civil work that links it up to the site improvements.